Today's lesson was about finding distance between 2 points, or in other words, pretty much using the Pythagorean theorem. So it looks like I have point 1 and 2. I'm going to go ahead and draw a line so that I can figure out what my hypotenuse is going to be. So there's my hypotenuse, and I can draw the legs of the right triangle however I want. I'm just going to go down this way and to the right this way. And all I have to do is count my number of units. This is where my 90-degree angle is going to be. So I have 1, 2, 3, 4, 5 for my rise. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 for my run. You need to remember not to count the number of lines, but count the spaces for each unit. I'm going to label this one A and this one B. So now I need to find C. So the formula for a Pythagorean theorem is A squared plus B squared equals C squared. My A is 5, so I have 5 squared. My B is 9, so I have 9 squared. And then I don't know C. That's what I'm trying to find out. So I have 25 plus 81 equals C squared. So 25 plus 81 gives me 106, and that equals C squared. I don't need C squared, I actually just need C. So in order to get rid of the square, I need to square root both sides of the equation. So my final answer is square root of 106 for the hypotenuse. Now to practice simplifying my fractions, I'm going to go ahead and figure out my factor tree over here. So since it's an even number, I can divide by 2, and that works out since I want to go ahead and find my primes. So I end up with 53 over here. 53 is also a prime, so that means that square root of 106 is actually already simplified. The next one for P1 and P2, I'm going to go ahead once again and connect the 2 points for my hypotenuse. And it looks like it's going to be a much smaller triangle. Here is my A and my B, and remember it can be A here or B here, but I just prefer to label everything the same just for me to remember. So formula again, A squared plus B squared equals C squared. A in this case is 1, B equals 2, and then I don't know C. So A is 1 squared plus 2 squared equals C squared. So 1 plus 4 equals C squared. So 5 equals C squared. Once again, I don't want squared. I want to square root both sides. So I end up with C equals square root of 5. And I know that square root of 5 is already at its simplest, so I'm not going to go ahead and simplify that. My next one, go ahead and draw the hypotenuse again. I'm going to go ahead and go this way this time, just so you can see the difference. I have 1 again, and 2 right here. Here's A, here's B. It looks like it's more of a repeat again. So I have A squared plus B squared equals C squared. A is 1, B is 2, and C squared I don't know. So I have 1 plus 4 equals C squared. So I get 5 equals C squared, and I square root to get rid of the square, and I have square root of 5 again. So it's a repeated answer to this one. And we have one more, and it looks like a much larger triangle this time. I'm going to go ahead and draw my hypotenuse. I'm going to go ahead and draw my right triangle this way. Now remember that the Pythagorean theorem only works for right triangles. I'm going to count the spaces, 1, 2, 3, 4, 5, 6, 7. And I'll label this A, 1, 2, 3, 4, 5, 6. And that's B. And of course we're looking for C. Now, not every case you're going to be looking for C, but just to practice for tonight, we're just looking for C. So I have A squared plus B squared equals C squared. My A is 7 squared. My B is 6 squared. And then I'm not sure about C yet. So I have 49 plus 36 equals C squared. So I get 85 equals C squared. I'm going to square root both sides to get rid of that square since I just need C. So I get radical 85.